equations simultaneously, and then we'll get into matrices after a little bit. All right, whoa, here we go. So if we look at these linear equations, okay, when it comes on your computer, one will be blue, one will be red. Okay, if you want to figure out which one is which, you can just graph them out yourself on your graphing calculator if you needed to. But what do these look to be? Parallel. Okay, if you have parallel lines, will they ever cross? No. So if you have parallel lines, it'll be no solution. Now, a way to check that is look at the slope. What's the slope of this one? Okay, instead of getting y alone to find the slope, sometimes it's easier to go negative a over b, because it's ax plus by equals c. So negative a over b equals negative 2 over negative 6, which is a positive 1/3. Does that look like a positive 1/3 slope? Rise of 1, run to the right 3. Yep. So it looks right. If we look at the second one, we have negative 3 over negative 9, because it's negative a over b, which is a positive 1/3 slope. Since they have the same slope, they're parallel. Since they're parallel, it's no solution. What if they are on top of each other? Then it's infinitely many solutions. So looking at this, okay, to figure out if it has one solution, no solutions, or infinitely many solutions, you find their slope. What's the slope of the top one? If we go negative a over b, it would be negative 4 over 7. If we look at the bottom one, negative a over b is negative 7 over negative 6, which is 7/6. Are they the same slope? No. So there should be one solution to the equation. Just find their slopes. If their slopes are the same, then you check their y-intercepts. If their slopes and y-intercepts are the same, then it's infinitely many solutions. If their slopes are the same, but their y-intercepts are different, then it's no solution. Okay? Looking at this one, what's the slope of the top one? Negative 8 over 2, which is negative 8 over negative 2, which is a positive 4. Slope of the bottom one, negative 12 over negative 3, which is a positive 4. So they have the same slope, so we need to check their y-intercepts. C over b equals the y-intercept. So 4 over negative 2, for the top one, it's 4 over negative 2, which is a negative 2 for the y-intercept. For the bottom one, it's 6 over negative 3, which is negative 2. They have the same slope, same y-intercept, so it is infinitely many solutions. Okay? So you just have to look, figure out their slope, figure out their y-intercept, see what kind it is. Okay? For this one, I would graph on the graphing calculator. But to graph the second one on the graphing calculator, what do? Get y alone. Okay, so 4y equals x plus 1. So y equals 1/4 times the quantity of x plus 1. Okay, or x plus 1 divided by 4, or x over 4 plus 1/4, however you want to do it. Okay, you'll get one of these graphs, and it's probably this one right here. Okay, because there's this positive slope, and the other one opens up, so it has to be B. And then you'd use your graphing calculator to find the point where they intersect. So it's second trace intersect, and find those 2 points where they intersect. Type them in there. Okay? Equilibrium point. You got to figure out where these supply and demand are equal. Okay? That's the equilibrium point. So since they're both equal to P, you can set them equal to each other. So 11,300 minus 50x equals 300 plus 60x. So if I add 50 to each side, 11,300 equals 300 plus 110x. Subtract 300, 11,000 equals 110x. Divide by 110. X equals 100. Okay? So if x is 100, stick 100 in for x, and then you stick 100 in for x of the equation to find p. So 600 plus 300 is 900. Oh, it's 6,000. So it's 36 or 3,300. More like that, huh? Yeah. Okay. Okay. A rectangle. I think this is a test question, so we better make sure we know how to do this. A rectangle has an area of 64 inches squared and a perimeter of 40. The perimeter equals 40 and the area equals 64. All right. So looking at this, you have a length and a width. Area equals length times width. Perimeter equals 2 length plus 2 width. Okay? So 64 equals LW. I can get W alone. What does W equal? 64 over L. And then I plug the 64 over L in for W down here. So my perimeter 40 equals 2 times L plus 2 times 64 over L. Okay? So I got to solve this thing somehow. Okay? So 40 plus, or 40 equals 2L plus 128 over L. To get L off the bottom, I multiply everything by L on both sides. So 40L equals 2L squared plus 128. We move the 40 to the other side. 2L squared minus 40L plus 128 equals 0. Okay? Then what do I have to do? Factor. I would take out a 2 first and get L squared minus 20L plus 64 equals 0. L and L, minus and minus, 16 and 4. So L minus 16 equals 0. L minus 4 equals 0. 2, you just divide both sides by 2, so that just disappears. So the length equals 16, or the length equals 4. If the length is 16, 64 divided by 16 is 4. So 1 is 16, 1 is 4. So if this would be 16, that would be, if this would be 4, this would be 16. So the dimensions are 16 by 4, because 16 plus 4 plus 16 plus 4 is a perimeter of 40. 16 times 4 is an area of 64. The smaller in the first box, the larger in the second box. 4 times 16. Okay? So you do have to do a little more work on some of these, a little factoring involved there. Okay? Boat crew. These are always fun, and you don't do enough of these in Algebra 2, so that's why we do them again here. Okay? Boat crew rowed 13.5 miles downstream with a current of 1.5 out with a current in 1.5 hours. The return trip against the current, the crew covered the same distance but took 4.5 hours. What's the crew's average rowing velocity in still water and average velocity of the current? So rate times time equals distance. So they're going downstream and upstream. The rate going downstream, we don't know what it is, okay? But it's their rowing rate plus the current rate. The time it took them is 1.5 hours. The distance they covered is 13.5 miles. The rate going back upstream, they're fighting the current. So it's whatever their rate is minus the current, because their current is holding them back. Took them 4.5 hours, and they went 13.5 miles again. So what you do, I don't know what just happened there. So what you do is you multiply, you take 1.5 times R plus C equals 13.5. And 4.5 times R minus C equals 13.5. Okay? Now, I could distribute through if you wanted to, or I could divide on each side. What's 13.5 divided by 1.5? Somebody. Calculador, por favor.
16.
No. R plus C equals 9. What's 13.5 divided by 4.5? 3. Now, these are very simple equations to solve. If we add 2R equals 12, the rate of still water is 6 miles per hour. Plug 6 back in, what's the current going to be? What's 6 plus what is 9, and 6 minus what is 3? 6 plus what is 9? 3. So, their velocity in still water rowing the boat is 6 miles per hour. The velocity of the current is 3 miles per hour. So 6 plus 3, they're going 9 miles an hour downstream. For 1.5 hours, took them 13.5 miles. 6 minus 3, because they're going against the current, they're only going 3 miles per hour. Times 4.5 hours, took them 13.5 miles. Okay? Plane speed is the same thing. Okay? So we'll show one more problem, and then I'll let you get going on these before we do get into matrices a little later in the period. Rate times time equals distance. Okay? Our airplane took 4 hours to fly 1,200 miles against a headwind. So the speed of the plane plus the speed of the wind. Well, the first trip was against the wind, so minus the speed of the wind, and the speed of the plane plus the speed of the wind. Okay? So going there, that's our label. Against the wind, with. So they're going speed of the plane minus the speed of the wind. Took them 4 hours, and their distance is 1,200 miles. Speed of the plane plus speed of the wind, 3 hours, 1,200. So 4 times S minus W equals 1,200. 3 times S plus W equals 1,200. If I divide by 4, 1,200 divided by 4 is 300. So S minus W is 300. S plus W equals 400. So if we add our columns, 2S equals 700. So S must equal 350. 350 plus what makes 400? So the speed of the plane is 350. The wind is 50. Okay? So there's 8 problems for you to do. I'll give you till 10:30 to work on these, and then we're going to start matrices.